Good afternoon, everyone. On behalf of Institute of Indian Foundrymen, Chennai chapter and Coimbatore chapter, I would like to extend a warm welcome to all of you who have joined us today for our technical program on development of quality cost analysis. We are honored to have with us today Dr. M. Arasu, HOD, Foundry Technology at PhD Polytechnic College, Coimbatore, who will be presenting on this topic. His extensive research in this field has been recognized by many, and we are thrilled to have to share his knowledge and insight with us today. The Institute of Indian Foundrymen has always been committed to promoting technical excellence and innovation in foundry industry, and this event is a testament to our continued efforts towards achieving this goal. We believe that this program will provide a valuable learning experience for all of us and will equip us with the necessary tool and knowledge to stay competitive in today's rapidly evolving industry. I would like to extend my gratitude to both Chennai and Coimbatore chapter for their joint effort in organizing this event, and to all of you who have been taken the time to participate today. I hope that you find this program informative and encouraging, and that you leave with a greater understanding of importance and quality cost analysis in the foundry industry. Thank you, and once again, welcome to our technical program. Yeah, thank you. And I request Mr. Ramanand to introduce our speakers today. Raman sir. Dinesh.
Sir.
யாரப்பா இன்ட்ரோடியூஸ் பண்றாங்க?
ராமன் சார் இருக்காங்க சார். ராமன் சார்.
Yeah, good afternoon, sir.
Yeah, good afternoon, sir.
Thank you very much for giving me the opportunity to introduce Dr. Arasu to this August gathering. Am I audible?
Yeah, yes, sir.
Okay. Dr. Arasu is a professor and head of department of Foundry Technology at PSG Polytechnic College, Coimbatore. Educational part, completed degree in mechanical engineering and ME in production engineering at PSG, and doctorate PhD in Foundry Technology at Bardiyar Institute. Having experience of 28 years and life member of many organizations like Society of Technical Education, Indian Institute of Metals, International Red Cross Society of India, and the member on the Great Indian Institute of Indian Foundrymen and Institution of Engineers, India. Published many papers, around 50 papers he published, comprising international and national journals and for international conference, and prepared technical guide for Foundrymen, which was published at IIF Calcutta, and a handbook of Metallica, which is an encyclopedia on metal castings published by IIF Calcutta and published by JS Publications, Madurai. Having responsibility of convener for Technical Session Committee of 60th Indian Foundry Congress in 2012 at Bangalore, and the 64th Indian Foundry Congress in 2016 at Coimbatore. Held many positions like Treasurer, Secretary of IIF between 2014 and 18, and presently Executive Council member of IIF Southern Region since 2016. Technical Committee member of IIF Coimbatore from 2018 onwards, Secretary of Indian Institute of Metals, and General Secretary of PhD Alumni Association since 2008. Got many awarded, namely certificate for Best Program Officer in the year 2002 by Bardiyar Institute, State Level Best District Organizer Award by the Indian Red Cross Society Tamil Nadu branch in 2005, and Best Teacher Awards for the year 2016 of PSG institutions. The Teacher Day celebration September 16, Best Faculty Award for the year 2018 by Nehru Group of Institution, February 18. So his achievements and awards are continuing. Now I request Dr. Arasu to present his valuable presentation to this August gathering. Over to Dr. Arasu. Thank you, sir. No?
So thank you, sir, Mr. Ramasa, for your elaborate introduction. So I am very delighted and honored today joint technical program organized by the Institute of Indian Foundrymen Chennai chapter and Coimbatore chapter under the umbrella of IIF Southern Region. I am very happy to present today my technical paper. It's my part of my research work and continuation of my interest on energy and quality. Do you want to directly go to the presentation? Is presentation visible?
Yes, sir.
Yes, sir. Visible.
Yes, doctor, it is
Thank
visible,
you, sir.
visible.
Today's title is Development of Quality Cost Analysis. And the background of this concept is taken from it's a Japanese concept developed by Mr. Juran. So the
You can make
famous
it a full
author of-
screen, sir. Doctor, you can make it a full screen.
Now it is.
Yeah, clear, clear, doctor.
Thank you. The concept began of the cost of quality is from Mr. Juran is a famous author of Japanese. He developed the cost of quality. Had taken this concept cost of quality and applied in our found industry. So mainly you can see the top management looks at every activity in the organization in terms of return on direct and indirect investment. However, this does not mean that they are looking for short-term gain only. They don't mind waiting for years if ultimately the efforts are going to pay out. The management will adopt either ISO 9000 or TQM if it is going to help the organization. In fact, many foundry industries in India have adopted ISO 9000, ISO 14000, TQM, Six Sigma, Kaizen, etc. for growth of coupled with productivity, quality as well as profit. So the TQM was evolved to satisfy customer in the most economical way. The quality means cost effective. So the TQM aims at a gradual reduction of wasteful expenditure and eventually the total elimination of the defects. In this background, we shall move to the presentation. Today the GISTA presentation is introduction is for, then cost of quality, I introduce a new concept, and then quality assessment study of various resource, analysis of casting defect using 7QC tool, one of the important tool of cost and effect diagram, and rejection cost analysis, and I developed an expert system for rejection prediction. Finally, we have conclusion of the presentation. Everyone know the foundry is a metal shaping process of forming metallic products by melting the metal, pouring it into a cavity and allowing it to solidify. The foundry industry is on the threshold of technical revolution continuously. The foundry industry is highly energy intensive, not only energy intensive, manpower intensive and also raw material intensive also. The foundrymen are in the inevitable position of having to produce the best of the castings at the lowest cost possible. Foundries are operating in a very competitive environment. Generally, the productivity of foundries needs to be improved as most foundry are having low yield. The yield to conserve energy in foundry industry is of considerable importance in view of the rising cost and shortage of fossil fuels. Foundries need to reduce production cost through improved quality and reduced rejection.
It is a slide is external failure cost.
Okay,
Yeah, now
sir.
it is changed.
Thank you, sir.
Yeah, changed.
Let's go for the cost of good quality. First one is appraisal cost. So appraisal cost is nothing about the cost associated with the measuring and monitoring activities related to quality within the both industry as well as the supplier and customer end. To evaluate the materials as per the standard specification norms and process, product, service to ensure the confirmation of the specification given by the customer. It includes, say, example, verification. Say, example, the incoming checking of incoming materials, process setup, product against the agreed specification based on the customer and supplier or customer or vendor, and internal quality audit and supply rating. This all comes under category of appraisal cost. Next is a prevention cost. The prevention costs are incurred to prevent or avoid quality problems. So this cost associated with this exam design and implementation and maintenance of QMS, quality management system. So example, product or service requirement, specification for incoming material, process, finished product and service, and QP, quality planning. There is advanced product quality plans also there. APQP, creation of plans for quality as well as reliability, operations, production as well as inspection. QA, quality assurance and training, both develop and preparation maintenance of the training program and the related documents. So those activity to prevent that defect, this cost are associated with the prevention cost. So prevention cost, appraisal cost comes under category of cost of good quality. Internal failure cost and external failure cost comes under category of cost of poor quality. So I put the consolidated slide, the cost of good quality as well as cost of poor quality. Now you can see the graph. This is optimum quality level with both internal failure cost and external failure cost. You can add the total cost of quality. With reference to this cost of quality, now we go for the exams of how to study the various important process parameters to influence the productivity in the cast and foundries. So I take the important parameters. One is the raw material, another one is the processing method and melting practice, pouring practice, and skill of manpower, either operator or labor. I will take in the 4 foundry with the range of the volume of production from 6,000 to 12,000 ton in the 4 foundries. I put the performance rating factors. Say example, they are the good, very good practice means 8, excellence means 10, good means 6, low means 2, average means 4. It's the rating factors. Now take the 10 parameters for qualitative assessment. Standard of usage of the metallic raw materials, testing of incoming materials, refractory material used, quality of binders and additives, selection of pattern material, quality of core sand preparation, quality of molding sand preparation, and sand reclamation practice. I take the 10 parameters. These 10 parameters are applied to 4 foundries. So foundry A, the rating is shown this slide. Foundry B, the quality. Again, I take the first is a qualitative assessment for raw materials. Here I shown the 5 parameter, no? Raw material, processing methods, melting practice, pouring practice, skill of manpower. So first, the quality assessment of raw material for 10 parameters. Then quality assessment of processing method. Again, I take the 10 parameters for uniformity. There is some more parameters. I take only 10 parameters to influence the major quality assessment study in the processing method. Equipment, machinery of operating at a designated capacity, plant layout, maintaining the effective inventory system, instrumentation for energy measurement, effective communication system, effective design of feeding mechanism, effective plant maintenance. So I put the consolidated slide, the cost of good quality as well as cost of poor quality. Now you can see the graph. This is optimum quality level with both internal failure cost and external failure cost. you can add the total cost of quality. With reference to this cost of quality, now we go for the exams of how to study the various important process parameters to influence the productivity in the cast and foundries. So I take the important parameters. One is the raw material, another one is the processing method, and melting practice, pouring practice, and skill of manpower, either operator or labor. I will take in the 4 foundry with the range of the volume of production from 6,000 to 12,000 ton in the 4 foundries. I put the performance rating factors. Say example, they are the good, very good practice means 8, excellence means 10, good means 6, low means 2, average means 4. It's the rating factors. Now take the 10 parameters for qualitative assessment. Standard of usage of the metallic raw materials, testing of incoming materials, refractory material used, quality of binders and additives, selection of pattern material, quality of core sand preparation, quality of molding sand preparation, and sand reclamation practice. I take the 10 parameters. For these 10 parameters are applied to 4 foundries. So foundry A, the rating is shown this slide. Foundry B, the quality. Again, I take the first is a qualitative assessment for raw materials. Here I shown the 5 parameter, no? Raw material, processing methods, melting practice, pouring practice, skill of manpower. So first, the quality assessment of raw material for 10 parameters. Then quality assessment of processing method. Again, I take the 10 parameters for uniformity. There is some more parameters. I take only 10 parameters to influence the major quality assessment study in the processing method. Equipment, machinery of operating at a designated capacity, plant layout, maintaining the effective inventory system, instrumentation for energy measurement, effective communication system, effective design of feeding mechanism, effective plant maintenance, right kind of molding practice, right kind of core making process, effective material handling system. Again, put the rating. This rating I will taken from I got the foundry. I interact with the 3 level of operating level, molder, operator. I can interact with the engineers and supervisor, then I interact with the manager. So I take the 3 samples. The average of these 3 samples only I put this parameter. This quality assessment study of melting practice. Again, I take the 10 parameter. Furnace lining preparation, monitoring molten metal temperature during melting, core bed preparation in cupola or melting furnace, molten metal holding in the furnace, monitoring superheat, raw material weightage, charging makeup consistency, consistency of alloy addition, practice, monitoring tapping temperature, consistency in the rate of heating. The 4th parameter, pouring practice, lining of ladles, ladle heating, handling of ladles, correct size ladle with the heat retaining covers, intermittent use of pouring ladles, time taken to pour up small mold, less than 50 seconds, all molds are poured within 25 seconds, ladles loading, mold pouring station distance, and drying of ladles. The last parameter is the skill of manpower. The various department, sand department, pattern making, core making, molding, melting, molten metal pouring, fettling, shot blasting, secondary process, grinding, machining, heat treatment, welding, like that. Then finally say testing and inspection. Like that I take the 4 foundry. This I shown the detailed foundry A. So I taken the foundry B, C, D also. And I put the consolidation of the comparison of the 4 foundries with reference to processing of raw materials. Now you can see the how the performance of foundry A, B, C, D with reference to raw material. I put the total score. So foundry A, it's there are some good practice. P and say it's also okay. D will be improved with reference to raw materials. I can see the comparison of processing method with reference to Foundry A, B, C, D. Now you can see the again Foundry it's okay. Now second is the Foundry C, but the raw material is a Foundry B is a second, but in the usage of process method for C is a second, then B is a third, and D is a fourth. And go for the melting practice. Again, you can compare the performance of 4 foundries with reference to pouring practice and comparison of, with reference to skill of manpower. This is a consolidated bar chart showing the cumulative assessment of the 5 resources in the Foundry A, B, C, D. So it is observed that the Foundry A has a good industrial practice with Foundry B and C needs to it. However, Foundry D needs to improve in all dimensions. The efficient operating procedure leads to reduction of waste as well as improvement of the energy conservation as well as the productivity. So what are the key factors that influence the productivities? And now the percentage of yield is nothing about the total weight of the soluble casting, total weight of metal melted. So the major factors influence for yield is the gating and feeding design, melting and pouring, and defective castings. So the observation based on the first for the quality assessment study, the productivity is 50%, which is much low for the energy intensity industries like Foundry. Therefore, by improving the productivity and reducing the energy consumption, by targeting the quality of the various resources, the 5 resources, and also productivity can be enhanced. The productivity can be improved by reducing the rejection and maintaining the rejection records to identify the scrap loss caused by the pouring metal at temperatures that are high or too low. Based on the inputs, now move to the rejection analysis. In foundries, the substantial proportion of rejection result from lack of shop floor supervision and technical control and the use of poorly maintained and inadequate equipment. The rejected castings can only be melted and the value addition made during the various processes such as melting, molding, fettling and heat treatment is lost irrecoverably. Process variables that influence the rejection needs to be analyzed by the use of cause and effect diagram. So the methodology applied for the casting rejection analysis, we took the classification of casting defects, then process variable. By using that variables, we can prepare the cause and effect diagram. The defects and applied to the cause and effect diagram, you can go for experimental study and allocation of cost of quality. Then we go for casting rejection analysis. Next, move on to the cause and effect diagram. So before looking at the feature of the cause and effect tool, Newton's law says the motion may be recalled. According to the Newton's law, there can be no effect without any cause. If the quality is bad, it is due to the many causes, both known causes as well as unknown causes. So the cause and effect diagram helps the user to understand and a list of all the possible causes and effect or desired effect. So it is explore all the potential causes or its inputs that result in the single effect or output. So it is used to identify the areas where there may be problems and to compare the relative importance of different causes. When a defect is encountered, the process should be studied and at least a few parameters causing the defect must be nullified. These parameters should be studied before starting an action plan for the minimizing of the defect. So the sample cause and effect diagram. Now you can see the template of the cost and effect diagram. There is a 4 parameters influence any process. One is the manpower, the operating of the skill of manpower, the machines, equipment, systems, then materials, the either raw material, in-process inventories or semi-finished goods, and then methods, techniques and technology. These 4 are major parameters to influence the process, any process. Okay, there is a first, it is also called fishbone diagram. The first line are shown the causes, the subdivisions called the subcauses. So this is how you can develop the construct the cost and effect diagram. First to identify the end objectives. These end objectives. So construct the skeleton type of fishbone diagram. Identify the main causes. Say example manpower, machine, material, method. Then for each main cause, you can identify the next level of causes. It's a cause 1, cause 2, cause 3. It is possible you can go for again subcauses for each causes. So analyze the causes and make the recommendation. Based on the recommendation, we take the action. You can see the example of cause and effect diagram for molding process. How the poor quality molding will happen means, other than the fishbone diagram it tells. I take the 5 parameter to influence the quality of molding process. One is the cold test, another sand preparation, mold closing and handling, and the returns are used, and mold making. So example mold making, the causes you can see the poor screws pressure, worn out pin and push, insufficient jolting, moldability index, molding hardness testing in damaged mold box, type of molding machines, quantity of sand added, weight of molding box, sand match plate, times of compaction, poor surface finish. So each this kind of causes I list out for the return sand, mold closing and handling, cold test and sand preparation. It's give very strong insight for any operators, supervisor to understand how these various causes to influence the quality of molding process. Likewise, this is pattern, how the poor quality pattern will happen. Again, pattern elements, methoding, pattern maintenance, and pattern making. Again, the reference to molding sand, how the poor quality mold sand will happen means bentonite, base sand, sand plan, sand testing 1, sand testing 2. To the various guys are divided into sand testing 1 and 2 to cover all the sand testing methods. Start with the moisture content, AF's grain size, flowability, refractiveness, permeability, clay content, gain, shear, strain, compression strain, moldability, hardiness, cogginess, compatibility, grain shapes, grain size distributions. Now based on telepathy, you can see the moisture content, clay content, grain distribution, sieve analysis, basicity, refractiveness, grain shape, and grain fineness number. Now another diagram for you can see the core making process. Get into the core preparation, core means core coating, core setting, core baking, and core box. Now you can see core coating means mixing in section, equipment not clear, equipment not cleaned, uneven application, improper coating, coating dried, coating not dried fully, allowed to stand for a long time after mixing. So the major listed is a skill reference to coating practice and casting defect. This is by using the cost diagram for the couple of finance, mold metal preparations, inoculation, daily rejection record, solidification process, pouring, daily reseparation and composition control. You can put the various spot number. So composition reference to pouring pressure, the pot, metal component number, spectrometer, defect content, carbon exams and quality mold metal separation, inoculation, extra. The modification process, pouring, how many heating defects, composition, these cast component, intermediate operation, In composition control, you can see the desulfurization, additional rejection data, chlorlining, carbon equivalent, quality temperature, maintaining correct rejection records. The motor will enable quality measurement should be assessed proper certification to indicate loss of its intermittent operation, correct linkage charge persons of gas, inconsistent cooling of surface, excessive superate, chlorlining collection of data regarding the property gas, incorrect certification. This rejection record sheet can be used as a weekly summary proper certification. The details actually recorded in secondary process, cooling time, fluidity, the requirements of gas about the cooling of surface, liquefaction of grain. So you can persons of absorption of gas, wetling, then proper certification go for grinding, heat related record sheets. Sectional fatigue means in secondary process you can see the bad handling. Secondary process is nothing about proper tool, repair welding, existing component. Exam heat before, then feeding, then soft temperature, taken from the foundry, go for grinding, heating, next molding, B4 temperature, B1 to B4 is a heating furnace. Exam means engage support of B1 proper handling, foundry. Improper each foundry repair welding, taken from four components. Exam heat treatment means delay heating, insufficient temperature, extra loading, the rapid heating, defects of molding recorded, poor temperature process, how they sand in heat treatment furnace, compound lack of A, support of casting, one proper handling and A002, surface A003 on the casting, A004, paper film sand in during quenching process, delayed quenching, or even selection of quenching medium. So this kind of based on the record sheet, even maintain heat treatment process. As a daily basis or weekly casting defect in the monthly basis. By using the cause and effect diagram, I can put the consolidated daily rejection record sheets. It is a sample daily rejection record sheet. Based on the rejection record, the various based on the rejection dimension, the cast what are the pot casting component number. By using the cost effect diagram, I can put the consolidated pot number daily rejection A001. You can mention how many defects in the east cast. You can put the various pot. Normally the price per casting is what are the pot. This rejection data collection. These are the defects listed. 1.5 into 150 maintaining cage blow rejection records. The total enable you can mention how many production defects indicate 240 case number control that particular month. Corrective action can be taken. So rejection is a daily rejection out of this rejection data collection. To consider the collection of data, usually a foundation value of rejection is this rejection recordable quality number of cases weekly assessed into the indicate 1.53 unit of testing. Very corrective action can be taken. The requirements of individual daily rejection record. Sample sheet 176 can occur if the collection of data regarding the rejection in foundries. You can modify the rejection column can be used as a weekly summary sheet. Column the details actually recorded being list of the value of rejection. Where you can see the price the requirements of individual foundry multiplied by the sample number of 16 components. The first foundry B004 taken from the foundry modify the next two ones B out of B1 to B4 is that foundry B. The percentage is 7.1 to C4 foundry C. The value of C is 1 B4 is foundry. So each foundry, I taken for four components. The first four, I taken from the foundry A. Based on the rejection, then the defects four. We can record rejection B1 to B4 is and foundry B to array the C1 to C4 component A101 to B4 is foundry A002. So each foundry I taken for four components solution. Mode lift rejected. The percentage 8.06. The this kind of defects rejection recorded maintain the each foundry. How they daily basis based on this component. So this is a rejection record sheet. Based on the rejection record sheet, we will prepare the rejection dimension sheet. Sir, now take the part number. Say example A001. The weight of the casting is 1.53 kg. Normally the price per casting is in the AGN is rupees 115 kg. The 1.53 into 115 is 176 rupees. The total production is 248 numbers that particular month. So rejection is 20 out of 248, 20 compounds were rejected. So the rejection percentage is 8.06. So the value of rejection is 20, number of casting rejected, 20 into 1.53 weight of casting into 176, or 20 into 176, you can put 3520. So columns 3 into column 7, we list out the value of rejection. The price per casting multiplied by the total number of rejections. So example D004. So total compound produced 216. Out of 16 compounds were rejected. The percentage is 7.41. The value of rejection is 11968. Now put the consolidated statement of rejection cost analysis in Foundry A for all 4 components. Value of rejections, for you can see example all 4 components 33,548. The value of good casting is 3,25,740. The recorded material cost at the rate of 45 per kg is 13,118. The net rejection cost is 20,430. So from the analysis of the rejection cost in Foundry A, it is observed that the net rejection cost is 6.27% of the total cost, which will increase the per kg of selling price of the good quality casting. So we will add the actual cost plus the 6.27, so 106.27%. Or otherwise, we can accommodate in the profit margin. Either you can add the selling price, or not possible, you can compensate in the profit margin. Like I prepare the Foundry B, C, D also. So based on that, I developed the expert system for rejection prediction for the casting foundry. The forecast of the amount of cast component that would be rejected in future is done through an expert system developed through linear least square regression model compared to the Visual Basic. The expert system developed is supported by both a linear least square method as well as the fault tree analysis and cost benefit diagram. Then applied to LL, the linear least square regression, the root cause of the defect is found out and the quantity of the cast component that would be rejected, the type of defect are predicted by the expert system. The solution when implemented in any foundry would reduce the casting defects and improve the overall productivity of the foundry. This is the equation. I developed the expert model. So equal to f of x comma beta into e. So the x is number of defects. The beta b0 b1 is a parameter constant and e is the error compensation. This is the sub equation sub q p1 and p beta. So to better understanding, I take one component for case study to apply the developed expert system model and take one component. List the various parameters. It's like machine molding, green sun process. I shown the mold harness, melting furnace, induction furnace, tapping temperature, everything, and mechanical properties and chemical analysis. Now we can see the compound A, the rejection distribution for the period of over 10 months. I have taken the 10 defects. I distributed in the various months. What are the defects of an actual defects occurred in the particular compound in the particular month. For the first 11 row, then I add the total rejection of the each cast defects. Say example, first month 137 defects, second month is 209 like that. Then I can show the total production for the particular month. So last two row shows the total rejection per month and total production per month. Now we can implement the casting defects reduction methods. Say example, in the particular component, the rejection is 3.2% due to the cold shed. So weight of the particular component is 9.6 kg. I made a small design modification in the gating system. The unit of good casting that can be produced is around 1000 kg. So in the 1000 kg, we can prepare around 104.17 units. By using the equation, so y equal to 0.026 into x minus 19.47. This is a faulty diagram for cold shed. You can see the cost simplification of the casting rejection due to the cold shed. So actually the cold shed percentage is 3.2%. After implementing the design modification system, the cold shed reduced from 3.22 to 1.2%. So number of defectives, now you can go to 3.2% is 0.32, 03232 into the number of units produced 104.17. So number of defective expected is 3.3 before modification. After modification is 1.25. The total cost producing defective compound is 3.33 into the cast compound is 9.6. The weight of the casting per kg is rupees 115. So the cost is rupees 306.76. So less material cost is 1439. Recorded material cost. The last per ton of the cast is 927. The power cost last per unit is 3.3 into 9.6. The 1 ton is rupees 18,576. These are the before modification. After modification comes 216. Now we can see how much material cost is saved from the 3676 to 1380. Recorded material cost from 1439 to 540. Loss from 930 to 348. Power cost saving from 576 minus 2000 around 350 rupees. So we will come into the presentation. So we discussed about the methodology for assessing the various resources used in the foundry, like raw material, processing method, melting practice, pouring practice, and skill of labor. And the cumulative assessment is made and overall rating is established for individual foundry. The qualitative assessment has given the insight into the best as well as the poor utilization of the various resources in foundry industries. So the foundry and pouring process have been identified as a key factor influencing energy consumption. It is also observed that the process variables studied have significant influence on the quality of casting. Based on the studies on the process variables influencing casting rejection, the cause and effect diagram have been developed for different process variables like pattern, sand, core making, mold making, raw material melting, pouring, and secondary process. The rejection cost analysis carried out the sample system cast component revealed that an average increase of 10% in net rejection cost occurred in the existing foundry practice. Due to the existing foundry practice, there is a 10% of net rejection cost. This is the major identification of this study. So the display of cost, my suggestion is, so display of the cost and effect diagram shall be made in the shop floor as a ready reference to know the possible causes of various defects. An expert system to predict the cast rejection is developed using the linear regression model. In order to validate the expert system model, one case study for various cast components have been taken. I think the 5 components. So due to time, I only show the only one component. So the rejection control measures implemented for the above cast components have drawn an average of 5% reduction in the casting defects interactions. Once again, thank you for giving the opportunity for both IIF Chennai chapter as well as Coimbatore chapter.
Fine, Doctor. So
Thank you, sir.
there's very interesting and very exhaustive also to compile everything within this 1 hour. It's a very big subject, in fact, Doctor. Nice to compile all those within 1 hour. So we can extend with one more session also. If time permits, maybe later.
Prabhu, members can ask question also. When I insist members to ask any questions is there.
Sure, sir. Sure, sir.
Members can ask doubts also.